Welcome to Security Architecture Podcast, where we help cybersecurity professionals to stay ahead of the curve and ensure they are successful in their cybersecurity journey.
Hi, I'm Evgeny.
Hi, I'm Dimitri.
We have here Gareth from Snyk. Can you please tell us about yourself and the company?
Yeah, thanks for having me, first off. So I'm Gareth Rushgrove. I'm the VP of product at a company called Snyk. We're focused on application security, but I think we focus there on developers. The developers ultimately are the ones writing the code, they're building the applications. How do you get them interested, engaged, and fixing security problems is really what we specialize in. So we can talk about how a bit later.
Right. So Gareth, where you see Snyk contributing the most in the DevOps CI/CD pipeline? Where would I plug in your tools?
Yeah, so I thought this was a great sort of visualization. So Snyk definitely, like I mentioned earlier, is a focus on application security, and the developers really is the sort of main user. So definitely those early stages, and like as developers are changing their code locally, we've got IDE tooling, we've got command line tooling. As they're committing code, we've got integrations with Git services, GitHub, GitLab, Bitbucket, whatever it might be. Teams as well, as they sort of, I guess those tools are useful for the individual, like those first tools are useful for the individual developers. Snyk then really helps like teams as well by integrating into the build process. So I think definitely the commit PR here, definitely build. There are lots of organizations as well that really integrate that at that sort of testing, unit testing, continuous integration stage. We provide like plugins for some test frameworks, or we've got, for example, an integration with Maven like natively. I'd say as well, though, actually, like a number of Snyk's customers also use Snyk in those sort of later stages. There's advantages to tools that come like at the left of this diagram, predominantly I think around helping you fix things, getting fast feedback to developers. But the risk of only being at that end is sometimes that you lose visibility of the thing that you're running in production, maybe in your business critical application. And like you sort of like that's the focus of like I think the security team often. Like, yes, they want to know developers are fixing things early, but actually they also want to know the vulnerabilities we have in production right now in order to help prioritize that work. So Snyk actually does focus in on the developers, and we do provide tools to help fix things. But we do provide tools for like the security engineering team, the security like sort of more audit side as well, to try and help them with the bigger, broader view. So I'd say there's aspect here, and our focus is definitely on those sort of developers and that early interaction point. But we do see Snyk used as a sort of like to audit ultimately what I'm running as well. We have a sort of broad range of tools there.
So Gareth, I'm wondering, you mentioned developers. What about DevOps, SecOps, or security analysts? Like, tell us who else use the tool.
Yeah, I think that nuance is often organizational specific. In some organizations, it's very much the developers themselves that have driven the adoption of a tool like Snyk. In others, it's like you say, like that's those sort of DevOps teams or even DevSecOps teams who are adding to an existing like mature build pipeline. Snyk sort of bridges that divide between, again, like providing local tools for individual developers to identify and fix security problems, but also then tools that make it really easy for people who are maybe not writing the code themselves, but are responsible for like an aspect of it. They're responsible for the build artifacts. They're responsible for the security of a given application at a more holistic level. We make it easy for them to integrate Snyk into like their workflows, as well as provide like that sort of aggregate level information. Like I guess like going from like an individual developer cares about the application they're writing at this moment in time. Like that's their focus then, and distracting them with a lot of other things is not a great idea. As you get further along that sort of pipeline you've got there from the sort of, again, like the DevOps teams, DevSecOps teams, security analysts, like they start broadening their view, I think, to saying, well, actually, it's less about the individual line of code. It's more about the application that's running here that serves this specific business need. So they start adding more context. Snyk tries to provide basically useful like reporting and aggregate data for that audience at the same time as tools that integrate into the developer tools they're using every day to solve the sort of actual fixing problem as well.
So it's kind of the both ends of the process, right? You want to discover everything as early as possible, but also provide assurance at the end when the application is running that there is no vulnerabilities.
Exactly that. Obviously, software never ends. People are always building and shipping new software. And I think the more you can help, like ultimately developers write secure software in the first place, but acknowledging that that's not enough. The world keeps moving. If I ship some code today, and I'm absolutely convinced it has no like vulnerabilities. I'm not using any third-party libraries that have no vulnerabilities. And I wake up tomorrow, turns out the world will have changed, and maybe there's a new vulnerability that's super important in something I did yesterday that was like there was no way of me knowing that was a problem. And you need tools that basically deal with both of those two things. It's not good enough to say, here's a list of vulnerabilities. You need to help developers fix them. But you can't just help them avoid problems. You need the full loop.
And how are you making them aware of that? So if there is a new vulnerability, how the developer becomes aware of that and what he's supposed to do with this information?
Let me jump into Snyk and show you how it works at a sort of high level, and I can help answer that question. Here's me logged into Snyk. Obviously, there's lots of other features and integrations. I'm not going to cover everything, but this is an example where I've previously imported a repository, basically a Git repository into Snyk. Here we can see that Snyk picked up a number of different artifacts and a lot of bits in that project. So this is actually a fairly typical sort of example. Like it's a Java application and we're using Maven. So we can see we found a pom.xml file. It's actually got a JavaScript front end in there as well that the Maven project build. We're actually releasing this as a container. So we're building a container using a Docker file. We actually have in here the code that will stand up a Kubernetes cluster as well to run this on Azure. We've got a deployment file for Kubernetes to run the application on there. And Snyk as a tool has picked up all of these different things. I think this is something else that we're seeing to your diagram of like sort of SCA and SAST as like sort of approaches. What we're trying to do is say actually the application is the center of that. And so Snyk is doing a bunch of software component analysis. We are doing a bunch of static analysis, but we're actually saying the heart of it is the application. Applications are getting this complex. Like these developers are increasingly writing configuration. They're writing code in multiple languages and they're using third-party libraries. And Snyk is sort of trying to say, actually, let's put that mental model at the center. Jumping into one of these, and this is the Java project. And we've picked out a number of different, and again, this is a good example where, I mean, this is a relatively small Spring Boot application that's already bringing in like 80 dependencies. And Snyk's giving you a sense of actually not just, I mean, like we can dig into all the dependencies, but from a security standpoint, we're sort of most interested in the ones that have vulnerabilities. And we can see actually, and this again is super common, it's often not the things you pick, it's the transitive dependencies of the things you pick that bring in vulnerabilities. We'll find things.
So I'm guessing you don't have access to the code.
In this case, no, we just need access to the manifest files that, like in this case, the pom.xml file. So it's that's describing it. Where we do have access to the code, though, we can go further. So ultimately, customers can sort of opt in there. If they want to give us a bit more access to the source code, we can actually determine, actually I can show a quick example. This is actually an example where they didn't share the source code with Snyk as much as basically made it like available to the local tooling. And as well as detecting those vulnerabilities, we've actually done some static analysis to really say, yes, you've got a dependency with a vulnerability, but is that something that's going to be actually called? So we're doing a bunch of basically static analysis to combine with that software component analysis and helping you prioritize the most important issues.
So you're doing simulation of execution and understanding the code flow to better provide information about what is exploitable and not just vulnerable.
Exactly, yeah. We're providing that extra context. Over time, people build exploits for some of those vulnerabilities. And some of those exploits actually then end up in like tools that are frankly really easy to use. And like you don't have to be a sort of elite sort of computer programmer to use Metasploit to exploit something that someone's created and sort of productionized an exploit. So again, like adding context to all these vulnerabilities.
I have another question. I saw something very interesting there. And there is the score I'm assuming this
yes.
is some score that Snyk calculates. Can you tell us a little bit more about it?
If you have vulnerabilities and you have a lot of developers and you have a lot of applications and you have a lot of time, the reality is that vulnerability management becomes something that you sort of expect it to be a small number and you've got suddenly got a large number. And it turns into, okay, so what should I prioritize first? And I think a sort of blunt way of doing that is people reach for CVSS. And obviously we'll show CVSS and we translate that into sort of severity around the CVSS scores. But CVSS is a fixed number and it doesn't really bring any context for you. It's useful for its purpose, but actually just using it as a blunt tool for prioritization avoids a load of other things. Like, as I said, like I was adding like whether something's got an exploit, whether something is actually reachable. And we have a bunch of integrations into things like Kubernetes. So if you've got misconfigured workloads, we can use that to help you prioritize vulnerabilities. Brand new vulnerabilities that are critical are something actually you often want to at least consider first. The struts vulnerability was a great example where it's brand new, it lands, it's important, and there were exploits really quickly. And that led to this whirlwind of like lots of compromises. That's something where you want that to float to the top of a list, not just be one of 100 important things to do. And that's why we introduced the sort of priority score that takes into account that severity, but also takes into account other items. So this is a good example where actually, I mean, this is a critical severity vulnerability anyway, but we have a fix available for it. So we're saying, this is critical. Like based on some static analysis, we think this is actually reachable and there's a fix available. Seriously, you should totally prioritize fixing this now.
Absolutely. And, it brings me another question, another observation that I'm seeing in this example that you are sharing with us. We can see that there is a critical vulnerability which has the highest score. Then we can see medium vulnerability, but it still has higher score than the high vulnerability. And I'm assuming the HMC been determined based on some industry standards, but your score actually says that, hey, it's more important to fix the medium one than the high one.
Exactly, yeah. I mean, in this case, I mean, I like that you picked that out. Like, again, it's nuanced. It's always going to be guidance, but in this case, this is actually a nasty vulnerability anyway. But this is absolutely something that this application is subject to. Like, this could happen, like based on sort of a high confidence level, based on that static analysis. And there's also a fix for this. So, yes, there's a vulnerability here, but you can fix it and you're exposed to it. I think in like the algorithm we've got is saying, yeah, that is actually more important, bang for buck for your time, than looking at this, which is an important vulnerability, but at the same time, there's not a fix for it. You're going to end up having to spend more time. That isn't to say this is not a more severe vulnerability, but from a priority standpoint, like you might reason about it differently. So there's some nuance there, and actually we've got some work coming to make that. So we're adding more signals to this all the time, but also we want to make it something that customers can configure, because they might have different opinions to us, which is fine.
Absolutely. Gareth, I have another question about what you showed before. If you go to the level of the repository, right? Some of the vulnerabilities, they're actually not coming from the software components, right? They're coming from misconfigurations. And I can see that you're identifying here Terraform templates. And would you find some potential risky configuration or maybe leaky or anything like that in Terraform file?
Exactly. I like that. And whether it's Terraform, whether it's Kubernetes or CloudFormation, increasingly configurations become code and it's alongside the application. And again, applying this, in this case, a Terraform file, deploying to Azure. And this is a bit pathological, but to your point of leaking keys, and this is something where actually someone's just put.
It's a high entropy string inside the file, which is a template, and someone need to look at it and verify that.
Yeah. So again, we'll provide information about like actually things we're finding and how to resolve them. And sometimes it's mistakes like that. In this case, someone's just gone like probably had a problem and they've run it and gone like, whatever, I'm just disabling encryption for this machine. And at a company level, you might have policies that say that's not okay. And Snyk helps you basically then like report and enforce on those. Maybe you've got a really good reason for that. And again, like Snyk has exception workflows when you can ignore that for a period of time or ignore it permanently for good reasons, and will like flow that through. And that's back to that sort of difference between the individual developer who's trying to get something done and the corporate and sort of security overview side of things.
Can you actually align the vulnerabilities that you are finding with the known standards like OWASP top 10 or MITRE top 25? And can you see that in the tool? Because many of the companies today trying to adopt different type of frameworks to create some general approach. Do you have such information? Do you have such mapping in the product?
CWEs basically are something that we thread through all of Snyk, and both the OWASP top 10 and MITRE top 25 have like used that framework as well. So we thread that throughout. And this is an example. Again, both those frameworks cover and really successfully actually broad security problems. It's interesting you picked up on the configuration sort of side of things. I always talk about like the misconfigurations on OWASP top 10 being like this forgotten, like no one ever talks about that one. And it's been there for ages. It's like we know it leads to problems, and yet we invariably focus on the sort of the other ones that are a bit more interesting. But yeah, so if you go through, like Snyk has like different tools that address a number of the different problems. A lot of them are related to the code you're writing. I mean, like, are you introducing like cross-site scripting is obviously one of the key ones on there. And this is more on the static analysis side of Snyk, where like if someone is saying, actually, I do want you to scan my source code, we can do. And worth noting as well, all of these tools we provide, and obviously the rich user interfaces I'm showing here, but we've got integrations into CI/CD systems. We've got this in IDEs. We've got this in CLIs, and you get all the same information in places. And this is providing both, obviously, context about like, well, what is cross-site scripting? It's providing a very detailed data flow of this application about how I wrote poor code in this case. But also interestingly, we're actually providing examples of how to fix it. In this case, this exact like we basically do a lot of machine learning behind this. So we're able to sort of find comparable examples from other public source code. And in this case, actually then provide a pretty concrete example of how to fix it. I can look at other ones as well and sort of go, right, yeah, I can better understand the problem and the potential solution.
Eric, I'm wondering, so I'm a developer, for example. I'm not, but let's pretend I'm a developer and doing my work. In one point, I'm going to do a build. And now you don't always have access to the code. So how can you fail a build, or where you will fail the build, and how you will let the developer know something happened?
We provide a number of different tools. The answer there is nuance in that different companies choose to use Snyk differently. And I think that's one of the advantages. So rather than trying to explode all of that, I can talk about, I guess, a common one. Locally, like a developer might be using, let's say, IntelliJ, and there's a mature Snyk plugin for IntelliJ, and that actually brings up in IntelliJ basically security information there. And like that's local to the developers' machines. They're obviously like they're working on the code, they have access to everything there. But let's say now you have submit your code into source control system, it goes to a CI build. Snyk can test there as well. We can also do some analysis of built artifacts. And let's say the case is actually, well, someone built this a while ago. You don't have the source code. It's a third party that's built this for you. This varies a little bit by ecosystem, but for Java, as we've been talking about that, if someone gives you a jar, Snyk can just scan the jar file. Jar files are less mystical than people think. It's really just a zip file with a bunch of metadata. And ultimately, we can read that metadata and, again, use our database of vulnerabilities to do that. So that works with some compiled artifacts. We just made an acquisition, actually, in this area as well of a company called FOSS-ID, and that has a huge, big database of basically hashes of source code from the internet and matching that to actually the versions of that been released. So we're doing quite a lot of like binary level, very quick matching of software that will allow us to extend this to some other ecosystems. We do some of this with containers as well. So if you just have a container image, someone's just give us a look, I've just got this container image, I want to run it, is it safe? Snyk can scan that using both looking at the package level information that's installed, but also looking at a number of artifacts there. I mean, like the Java one as well, but probably my favorite example is Go.
Will the developer get an email notification, some other notification about the problem?
Yes. So yeah, we've got a full range of sort of tools to get that information back to developers. Obviously, if they're integrating into their CI/CD systems, they've also got that built in. But Snyk can send emails both for sort of issues, but also often more usefully like periodic reports of status. So I get a healthy reminder of new vulnerabilities in projects each week from some of the projects I maintain. We also have native integration into Slack. So if people are moving away from email and into Slack, they can Snyk can follow them there. We also have a whole basically comprehensive API with Snyk, including actually some new webhook functionality. So if people do want Snyk to basically send them a webhook request for every new vulnerability discovered, and for them to do whatever they want with that, they can do so as well. So we've got a sort of like flexible tool chain there.
That's a good arsenal of notification integration. So people don't have to chase the vulnerabilities chasing them.
We also see, I think, like even further than that, some large organizations have like sort of vulnerability management programs with like big aggregation tooling, and there's quite a sort of a suite of tools in that space. We have loads of integrations and plugins for those as well. I think one of the things that Snyk focuses on is integrations into the ecosystem in which we live. Name a CI/CD system, we've got an integration there. Name it an IDE, we've got integrations there or coming. Name an SCM tool that we integrate there. Vulnerability management tools and reporting tools. Integration with Jira, we've got actually a first-party integration with Bitbucket pipelines as well now, so that's built in. We do quite a lot of work on the container side with Docker themselves, so like we're built into Docker Hub and into Docker Desktop. We've got a very wide range of integrations focused on the tools that developers use.
Aaron, this brings me to another question: how the license works? Like, is it per seat, per developer, per integration? Is there different tiers, different capabilities?
So, I mean, actually, to just try Snyk out, it's completely free, especially for individual developers. Like if you've got a little open source project, just go along to Snyk, sign up for free, start using it. You don't get some of the higher level like reporting capabilities. But if you're an individual developer with your hobby project, you don't need them. Like we still want you to be secure. We've then got ultimately a sliding scale of plans. So everything from a sort of small team, like a development team, maybe that is in a small company or actually just wants to make things secure without actually needing to deal with like bigger problems, can just sign up, come along, self-serve, put in a credit card, get going straight away. Up to like our larger sort of more enterprise-oriented plans. We bill on what we talk about as contributing developers, basically the developers that are actually benefiting from Snyk. Because obviously we've got lovely, rich tools, but what we find is that some developers do log into Snyk and use them. Others actually just benefit from all of those integrations I talked about. Like not all developers want another dashboard. That's absolutely fine. So basically what we say is actually, if you've got 10 developers working on an application, Snyk's helping secure, you're paying for them. All of those can log into Snyk if they want, but ultimately, like that scales with your development team. Like if you've got lots more developers, you're writing more code. Ultimately, you're getting more value, and yes, Snyk is more expensive, but it scales with that. So that I think we feel, and I think a lot of our customers feel, that's really like fair. It aligns with the value that a customer is getting.
And I'm assuming you are integrating with identity providers to allow seamless integration in enterprise environments.
Often developers don't want another dashboard to log into. Busy IT teams absolutely do not want another database of users, whether like we've got a whole single sign-on system that people use with their Active Directories or whatever it might be to integrate there.
Gareth, we have new vulnerabilities coming all the time. Do you guys scan the data all the time, and if something new comes up, you will say, hey, by the way, there's something new came, is it part of your code?
The view I showed you really with what we call projects in Snyk, one of the advantages of importing projects into Snyk is we can store enough information there, allows us to retest those things very quickly. There are new vulnerabilities announced every day. So we obviously aggregate a lot of public sources. We've got a dedicated security research team, so we do a lot of security research there as well. So we're very aggressive about getting vulnerabilities into our database. Every day, basically, we retest every single project within Snyk against that database. And so you're getting feedback incredibly quickly. So if new vulnerabilities are announced tomorrow, the example I gave, like I built something, it's fine. I went home, I came back the next day. If a vulnerability was announced there, I'm going to get an email or a Slack message or an API call from Snyk saying, sorry, there's a problem here that you need to address. So we're constantly monitoring those projects without any access to like back to the source. Like if you're changing the dependencies, obviously you can tell Snyk. If you're not, we can still tell you about new vulnerabilities in that application.
Thank you. I think we're done with the official type of part of the podcast. We want to move to open discussion if there's any questions to us, and we may have questions to you as well. Are you guys more SaaS, or people usually deploy your on-premises?
Yeah, so for the most part, Snyk is offered as a software as a service. Like I'm, again, keeping all of that infrastructure and the database up to date definitely benefits. And it also helps customers like onboard very quickly. For customers who really do need things locally, we do provide some options there as well. Generally speaking, that's for like larger regulated organizations. So we do serve things there, but the vast majority of our customers like prefer the SaaS model. That said, there's some nuance there. And actually, in lots of cases, organizations might have local source code systems or local container registries, and they don't want to expose those directly to the internet to a SaaS. So we actually have quite a hybrid model there. For those cases, we basically have a small bit of software that those customers can run on their side, but basically acts as a proxy. It allows us to communicate, but very restrictively. Like, so it's not that it basically shifts a small amount of the work to the customer's side. And what we find is that that's actually a lot more popular than having to deal with the whole running of something. Does a customer want to give us unaffected access to their entire source control system? No. Does a customer actually want to run Snyk on their infrastructure? No. Like the hybrid model with the Snyk broker basically alleviates that. They run a small bit of software on their side. It does some of the work locally, acts as a security boundary, and then you get the best of both worlds. Like they run something small that's actually pretty trivial to run. We run the big thing. They get the benefit. We do not get access to everything that they want to protect. So the hybrid model for our larger, more security sensitive customers is definitely.
The broker actually is the one that gets the direct access, for example, to the source code, and it extracts the metadata and only sends metadata that's required.
Yeah, and so we've got I think for customers who were just all in on SaaS for everything, Snyk's SaaS. For those that do want it to be a bit more nuanced, we can do so. For those that do want everything to be just on their own like AWS environment, they want everything to be ring fenced, and like we have a number of options there as well.
Is there an official name for that, like Snyk Hybrid or something?
We've not generally packaged it up as a separate product as much as we do talk about the broker around Snyk open source. And some of the other products that we have around containers, for example, have similar profiles for some of the specific integrations. So we have a native Kubernetes integration. I mentioned earlier examples where we integrate with the sort of production systems as well to give you more of an audit view. The Kubernetes integration does exactly that. It just looks at the applications you're running and provides vulnerability information back. All of that work actually happens on your own Kubernetes cluster. So like the images don't have to, like you don't send your container images over to Snyk. We don't get access to like anything other than you just install something and it will talk out as it scans things locally and again passes metadata over. That's still sensitive and we still treat it as sensitive data. But obviously it's a lot safer than sending your entire application source code out.
Another question that I want to ask you is actually your opinion about, you probably heard about the Sbomb initiative and Sbomb standards.
Oh, how long have you got? Definitely a hot button topic recently. I've been involved for a little while actually around this. I did a talk at FOSDEM about vulnerabilities in Cyclone DX. And I've been loitering and occasionally jumping in on the NTIA discussions around Sbomb.
The framing group?
Yes. Yeah. I think there's probably yourselves and people like me we've been interested in this for a while. What's super interesting the last few weeks is just the rocket ship of the executive order that's really kicked up interest in this. So I think both Cyclone DX and SPDX are both interesting. It's, again, parallel developments to an extent, but I think there's a lot of overlap and interoperability there. Do we end up with two things eventually? I don't know, but two things now is actually allowing innovation to happen without it all being blocked up along one thing. So I was actually just working on some tools with Snyk around SPDX3. So there's SPDX has been around for a while, but I think there's actually quite a lot of things that have been learned about it in the real world that are now getting translated into the new 3.0 standard. So I'm super happy to see that. There's drafts up for vulnerability information there that we've been implementing and playing around with. So there's a tool for taking the output from Snyk and giving you SPDX plus vulnerability information, which I'm super interested in. Vulnerabilities in Cyclone DX. I've got a pull request up against that project, making some changes to the existing schemas. Vulnerabilities are way more interesting than they look at first glance, and I'm a big advocate of that standards conversation. That I think now with the executive order, we're going to see the generation side of that really kick in. I was talking to the Linux Foundation, who owns the SPDX project, in particular about how do we get going with the actual consumption side of this. At some point, there's going to be now, I feel, a load of SPDX and Cyclone DX documents kicking around. Okay, how do we use them to make ultimately the problems that we have, like you said, around software supply chain, more transparent, more fixable? That I think is the next stage. And I think with the executive order, it's going to happen faster than everyone thought. And there's not been as much talk about consuming SPDX or Cyclone DX. There has been generation.
Right. Or sharing, if you talk about that. Right?
Exactly.
How you share that and who you shared it with without showing your crown jewels or secrets.
Exactly, yeah. So
if you had to choose, which one, Cyclone DX or SPDX?
I'm absolutely not going to answer that question. So I think ultimately, again, there would certainly be benefits to there being one. I think in reality, though, there is also a risk that comes from the acceleration here of premature standardization. The fact that there are two is allowing innovation to happen. I also think
there's actually three. There's also the Swede.
I think that solves a narrow problem and isn't seeing innovation. I think, but the working groups around Cyclone DX and SPDX in particular, I think are doing things that we're going to need that aren't ready yet. I think that's a good thing. I think that, again, the SPDX being under the Linux Foundation, I think, again, will allow more people, an influx of people to collaborate. It's a known model. Interestingly, just this week, and again, it might not pass, but the Cyclone DX folks are talking about moving under OWASP. And again, I think actually now, that actually being under a broader umbrella that can really advocate for it and act as a trusted umbrella, I think will be really powerful for adoption. So at some point, maybe there'll be downsides to two. I think the upsides to two now outweigh that, and I do like both bits of both. Having said that, on the vulnerability side, I have a bunch of specific feedback to the SPDX folks coming. They've got a pull request up, and I have one on Cyclone DX. But a bit like that, having some of the same people interested in both hopefully means they don't diverge a million miles. There's already tools for interoperability, which I think is a really good sign as well. So I totally avoided your question, but hopefully added some useful answers anyway.
Thank you very much. I think it was a great discussion. I learned a lot, definitely.
Thank you very much, and definitely was a very pleasant discussion.
And yeah, same. So that's always good. It's fun to chat about things.
Please remember to subscribe to our podcast and join us for our next episode.